Last class we have studied the concentration terms. Today we are going to continue with the topic called Henry's law. Today we are going into we did start Henry's law in the last class, so I'm going to revise the Henry's law. So what is Henry's law? Henry का लॉ आपको बताता है कि बेसिकली अगर आप प्रेशर अप्लाई करेंगे और द एप्लीकेशन ऑफ प्रेशर हाउ मच अ गैस इज गोइंग टू बी डिसॉल्व्ड इन अ सॉल्यूशन. तो प्रेशर के एप्लीकेशन से कितना गैस डिसॉल्व होता है इसके बारे में बताता है. तो फर्स्ट ऑफ ऑल इन द लास्ट क्लास आई टोल्ड यू what happened with the Henry's law that pressure is proportional to mole fraction of the solute. मान लीजिए आप कोई गैस डिसॉल्व करना चाहते हैं तो उस गैस का जो मोल फ्रैक्शन होता है वो मोल फ्रैक्शन जो कितना गैस डिसॉल्व होता है वो प्रेशर के ऊपर डिपेंड करता है. ओके, तो द प्रेशर डिपेंड्स ऑन द अमाउंट ऑफ सॉल्यूट दैट इज गोइंग टू बी डिसॉल्व डिपेंड्स ऑन द प्रेशर. बेटा ये हमने लास्ट क्लास में पढ़ लिया था तो जस्ट रिवाइज कर रहे हैं. अगर आपने नहीं लिखा था तो लिख लीजिएगा, ठीक है. अच्छा, इसके बाद जो होता है व्हेन वी रिमूव द प्रोपोर्शनैलिटी साइन इट बिकम्स kh into x. दिस इज कॉल्ड हेनरीज कांस्टेंट. Okay, so pH is equal to kh into x is the kh is the Henry's constant. This what we have learned. And one more thing we did learn in the last class is the if we draw the pressure versus mole fraction graph, so it is y is equal to mx graph. So this is a straight line graph where the slope is Henry's constant. Slope is represented by m. So we did cover this in the last class, right? Now this kh is Henry's constant. This is a very important point. The Henry constant kh is dependent on temperature. As we increase the temperature, the kh decreases. As we increase the write it like this. As we increase the kh, solubility of gas decreases. We can write it like this. So the kh is the inversely proportional to solubility. Okay, and since we know that on increasing the temperature, solubility decreases. Take a look at here what I am writing. Solubility decreases. So just correlate these two. On increasing the Henry's constant, solubility decreases. On increasing the Henry's constant, solubility decreases. On increasing the temperature, solubility decreases. So what will happen? kh is directly proportional to temperature. So on increasing the temperature, the Henry's constant will increase. Is it easy? समझ में आया ये? Now the kh is it is a very important point about Henry's constant. kh also depends on nature of gas. Write it down. kh depends on nature of gas. Nature of gas, nature of solvent, nature of gas, nature of solvent, and temperature. Okay, what do I mean by that? Suppose you have taken a nitrogen gas. If you are dissolving nitrogen gas in water, its dissolution will be different. And suppose you are dissolving nitrogen gas in petrol, its solubility will be different. This makes sense to you? Because I mean, obviously आप सोच सकते हैं कि अगर आप ऑक्सीजन को लीजिए तो ऑक्सीजन वाटर में हल्का फुल्का डिसॉल्व हो जाता है. दैट्स व्हाई द aquatic species such as fish and all those can breathe. But if I take the oxygen in petrol, it is not going to be dissolved very well. तो उसकी solubility कम होगी. तो जो solubility होती है वो डिपेंड करती है नेचर ऑफ गैस, नेचर ऑफ सॉल्वेंट एंड टेम्परेचर. तो एज अ रिजल्ट जो kh होता है वो भी नेचर ऑफ गैस, नेचर ऑफ सॉल्वेंट एंड टेम्परेचर पे डिपेंड करेगा. इज इट क्लियर? द नेक्स्ट वन. Now there's another question. Henry's constant, Henry law, that there's a different Henry law, that is the second formation of Henry's law. So second formation of Henry law is mass of a gas dissolved. What is it? Mass of a gas dissolved. Write it down. Mass of a gas dissolved is depends on pressure. Mass of a gas dissolved depends on pressure. Okay. So a mass is now here. This K is not Henry's constant. This is not Henry's constant. Remember this. This is not Henry's constant. I'm teaching you this because there's a question given in NCERT. Okay, based on this, that mass of a gas dissolved depends on pressure. But this K is not Henry's constant. This is simple normal proportionality constant. Is that clear? चलिए इसके कुछ एप्लीकेशन करते हैं. एप्लीकेशन क्या होंगे जैसे इसके, से फॉर एग्जांपल हमने अभी पढ़ लिया कि जो प्रेशर डिपेंड, जो आपका गैस डिसॉल्व होता है वो प्रेशर के ऊपर डिपेंड करता है. अगर आपका प्रेशर हाई हुआ तो गैस हाई होगी, गैस को जो डिसॉल्व होगी वो हाई होगी. तो डालिए हेडिंग एप्लीकेशन ऑफ हेनरीज लॉ. एप्लीकेशन ऑफ हेनरीज लॉ. ओके, सो सबसे पहला जो एप्लीकेशन होगा वो क्या होगा आपका, आपने देखा होगा सोडा बॉटल जो होती है, कोल्ड ड्रिंक वगैरह की बॉटल जो होती है, व्हेन यू ओपन अ कोल्ड ड्रिंक बॉटल, जस्ट लिसन टू मी प्रॉपर्ली, व्हेन यू ओपन द कोल्ड ड्रिंक बॉटल देयर इज अ फिजी साउंड, राइट? There is a fizzy sound. Where does that come from? Because due to the pressure of the, जो उसका lid होता है, pressure of the lid, there is a high pressure inside the bottle, so CO2 has been absorbed there. What gas is absorbed there? CO2. Carbon dioxide is dissolved in the bottle. और जैसे ही आप उसका ढक्कन खोलते हैं तो प्रेशर कम हो जाता है, और प्रेशर कम हो जाता है तो क्या होगा, आपका जो CO2 होगी वो सारी की सारी escape कर जाएगी. सी फॉर एग्जाम्पल आपने ये बॉटल होती है आपकी सोडा की बॉटल, तो यहाँ पे क्या है, बिकॉज ऑफ द लिड देर इज अ हाई प्रेशर, एंड हाई प्रेशर की वजह से क्या होता है, आपका जो CO2 होती है वो डिजोल्व होती है उसमें, और जैसे ही आप बॉटल का ढक्कन खोलते हैं वैसे क्या हो जाता है, प्रेशर कम हो गया, और प्रेशर कम हो जाएगा तो क्या होगा आपका, all the CO2 will escape, and as a result there is a fizzy sound. Is that clear? First point, there's a fizzy sound when we open when we open the soda bottle, when we open the soda bottle, because in the bottle at high pressure, in the bottle at high pressure, CO2 gas has been absorbed. CO2 gas has been absorbed, which on opening the lid, which on opening the lid escapes, making a fizzy sound. ओके, अब देखिए सेकंड एप्लीकेशन जो इसका होता है. ओके, व्हाट हैपेंस, व्हाई डू एट हाई एल्टीट्यूड वी फील नॉजियस? कैन एनीवन आंसर? एट हाई एल्टीट्यूड वी फील nausea. Why is it? I mean, we are not able to breathe properly, you can say in a simple term. Why is it?
The oxygen is not well dissolved in the blood.
Exactly. At high altitude, write down application number 3, second. At high altitude, there is a low pressure, there is a low pressure, there is a low pressure because of which oxygen does not dissolve well in the blood. अच्छा, आप लोग बायो के स्टूडेंट है. What does that mean in the biology context, that oxygen does not dissolve well with the blood? That oxygen does not bind well with hemoglobin. ऑक्सीजन, इसका मतलब हुआ इस सेंटेंस का, ऑक्सीजन डज नॉट बाइंड वेल विद हीमोग्लोबिन. इज दैट क्लियर?
Yes, sir.
बाकी लोग भी अपना वीडियो ऑन कर दीजिए. इट्स नाइस टू लुक एट द फेस ऑफ पीपल आई एम टीचिंग. I mean, after 1 or 2 class, we can close them. That's okay. But it's nice to know, ना, the people that I'm. Otherwise, सोचिए, मान लीजिए कभी मिला हुआ आपसे, आप तो पहचान जाएंगे, मैं तो जानूंगा ही नहीं कौन था. ठीक है. चलिए आगे आते हैं. अ थर्ड पॉइंट इज राइट ऑन. जो स्कूबा डाइवर्स होते हैं, लिसन पहले समझ लो अच्छे से. जो स्कूबा डाइवर्स होते हैं, दे सफर फ्रॉम अ पर्टिकुलर डिसीजेस. और जो हाई सी डाइवर्स होते हैं, दे पर्टिकुलर एक डिसीज से सफर करते हैं जिसको बोलते हैं बेंड. और बेंड्स प्लूरल होता है. ठीक है. सो व्हाट इज दैट डिसीज? देखिए, जब वो स्कूबा डाइवर्स होते हैं, जब वो डाइव करते हैं, तो उनके पास ऑक्सीजन का सिलेंडर होता है. और जो सी के अंदर क्या होता है, हाई प्रेशर होता है. तो ड्यू टू द हाई प्रेशर जो उनके जो ब्लड में होगी, वो ऑक्सीजन ज्यादा डिजोल्व होगी ना, जो गैस होगी वो ज्यादा डिजोल्व होगी. इज इट क्लियर? एट हाई प्रेशर, बिकॉज जब वो अंडर सी जाएंगे तो इतना सारा पानी होता है ऊपर से, तो उनका जो ऑक्सीजन होता है वो ज्यादा डिजोल्व होता है, या उनकी जो भी वो इनहेल करते हैं गैसेस वो ज्यादा डिजोल्व होती है. बट जब वो सडनली ऊपर आते हैं, जब वो सडनली ऊपर आते हैं तो प्रेशर कम हो जाता है. तो बॉडी जो होती है वो डीकम्प्रेस होती है. एंड ड्यू टू द डीकम्प्रेस क्या होता है, आपका बॉडी के अंदर गैसेस एक्सपैंड करने लग जाती हैं. तो उससे जनरली नाइट्रोजन की बबल बन जाती है. और वो बबल बहुत ही पेनफुल कंडीशन क्रिएट करती है. दैट इज कॉल्ड बेंड्स. इज दैट क्लियर? आई रिपीट अगेन. जो स्कूबा डाइवर्स होते हैं, जब वो डाइव करते हैं, तो क्या होता है, उनका प्रेशर बहुत हाई होता है. तो उस हाई प्रेशर में वो जो जो भी उनके गैस का सिलेंडर लेके जाते हैं, बिकॉज ऑफ द ऑक्सीजन लैक, तो उसका क्या होता है, वो जब एब्जॉर्ब करते हैं तो गैसेस ज्यादा डिजोल्व हो जाती है उनके ब्लड में. एंड जब वो नीचे से ऊपर आते हैं तो डिजोल्व गैसेस क्या होती हैं आपकी, एक्सपैंड करती हैं. बिकॉज इन द आउटसाइड एटमॉस्फेयर द प्रेशर इज लो, सो द गैसेस एक्सपैंड करेंगी. तो उससे क्या होगा, जो नाइट्रोजन के जो उनके बॉडी में नाइट्रोजन गई होती है, दैट फॉर्म्स a bubble, and that creates a condition of bends, which is a very painful problem. Is that clear? Can you write it on your own? Okay. अच्छा, एक चीज रह गई थी यहाँ पे, जैसे मास वर्सेस केपी का ग्राफ था. मास वर्सेस प्रेशर का जब आप ग्राफ खींचेंगे तो यहाँ पे भी जो स्लोप आएगा वो क्या होगा, के होगा. बट दैट स्लोप इज नॉट हेनरीज कांस्टेंट. रिमेंबर दैट. Henry constant because it has different properties. For example, I told you as the solubility of gas decreases, KH increases. So because of that, you have a particular name for it, which is called Henry's constant. Let's do a question. These are the fake values. That means they are not real values. I'm just giving you to make you understand. Helium. The KH value is 45, 30, 63, and 47. Or let's make it 54. Okay, which one is the most soluble one? Out of all the four, which one is the most soluble in water?
Oxygen, sir.
Oxygen is most soluble because its KH value is least
Low.
one. So it is most soluble. Is that clear?
Yes, sir.
Yes, sir.
Okay. Now this is another question I gave you in the sheet. If you had attempted it, you must have seen that. Say for example, I'm giving you these same gases. I'm not giving you the value of KH. Now I'm asking you which one is, sorry, I'm not giving you the value of KH. I'm asking which one is the most soluble in water. Out of these four, which one is the most soluble in water? This is the question from 11th class. I'll tell you the chapter is chemical bonding. This question, I'm giving you four gases. I have not given you the value of KH, okay? I'm giving you four gases and the value of KH has not been given to you. I'm asking which one is most soluble in water. For the hint purpose, this is a chapter chemical bonding in 11th. From there, this is the question. Which is the gas which is most soluble in water? Anyone? Take a guess. Okay, let's take a first gas is N2, second gas is O2, third gas is, let's make it a quiz. CO2. Fourth option is H2, sorry, ammonia. I bother. Let's see. That is not the real option. ठीक है? पता लगा. If you are raising for hand for N2, raise your hand if you want N2 to be answer. Okay, let's see. We'll go one by one. So anyone is for N2? Raise your hand. No one is for N2. How sad for N2, right? Anyone for O2? Come on, anyone. Okay, one person is for O2. Yeah. Okay. Anyone for CO2? Anyone for CO2? Okay, Suhang is for CO2. Okay. Who is for ammonia?
So NH3 ammonia.
Yeah. Raise your hand. Anyone else apart from Archana? No one. So what are you going to answer, rest of you? Leslie has also answered as ammonia. Anyone else? Okay, that's bad. I mean, you should actually attempt the question. It doesn't matter whether it is correct or incorrect. Okay. So Leslie and Archana has said as ammonia. So the correct answer is ammonia. Okay. Why is it ammonia? Because can you
So it's a polar
explain it, Archana?
molecules. So it's a polar molecules. I
Yeah.
guess that can form hydrogen bond with water.
Yes. Ammonia is a polar molecule which can form hydrogen bond with water. If you remember from chemical bonding, there was something called hydrogen bond. So if something can form hydrogen bond, it is going to be dissolved in water. So ammonia can form hydrogen bond with water. That is why it is soluble in water. Is that clear? Okay. Shall I move forward? Okay.
Yes, sir.
Next topic is something called vapor pressure. Write down the heading vapor pressure. Anybody knows the definition of vapor pressure? Okay, let's see. Pressure applied by, see, there is a solution here or solvent, it doesn't matter what you have taken. So what will happen? I'm closing this system. This is a closed system. Closed system means हमने इसे ऊपर से बंद कर दिया है बेसिकली. और केमिस्ट्री में वैसे क्लोज सिस्टम का मतलब क्या होता है? देखो, ओपन सिस्टम होता है जब मास एंड एनर्जी बोथ कैन बी ट्रांसफर्ड. क्लोज सिस्टम इज व्हेन ओनली एनर्जी कैन बी ट्रांसफर्ड. आइसोलेटेड इज व्हेन नीदर मास नॉर एनर्जी कैन बी ट्रांसफर्ड. ओके, कमिंग टू द पॉइंट. तो यहाँ पे क्या होगा? ये इवेपोरेट होंगे और व्हेन ये इवेपोरेट होंगे, इवेपोरेशन में क्या होगा? यहाँ पे वेपर कलेक्ट होते जाएंगे. तो द प्रेशर अप्लाइड बाय वेपर on the surface of the liquid. Pressure applied by vapor on the surface of the liquid is called vapor pressure. Write it down. Pressure applied by vapor on the surface of liquid. Pressure applied by vapor on the surface of liquid is called vapor pressure. So this is because there is only surface of the liquid is involved. So this is called surface phenomena. Because only the surface of the liquid is involved. So this is called surface phenomena. Okay. Acha, as opposed to when the inside of the, acha, can you tell me an example jahan pe inside of the liquid is involved, that is not only the surface. Let's make a boundary of the surface. This is the boundary of the surface. So when the bulk is involved, this is the called bulk. Can you give me an example where the bulk is involved?
Boiling.
Kya?
Boiling.
I'm not able to hear you properly.
Boiling.
बता दो बेटा.
Boiling.
Yeah, boiling is a, बिल्कुल सही बात है. Boiling is a bulk phenomena. Nice. Okay. Now apart from that, you can take an example कि say for example अगर आपने ink डाल दिया, okay, ink डाल दिया तो वो भी क्या होगी? पूरे अंदर तक चली जाएगी. तो that is also bulk phenomena. So this is a surface phenomena. The left factors involved in vapor pressure. Factors affecting vapor pressure. Factors affecting vapor pressure. चलिए, let's take a guess. What are the factors affecting vapor pressure? Think about it. Let's see if you can think about it. Anyone?
So temperature.
Yeah. As you raise the temperature, yeah, as you raise the temperature, vapor pressure will increase. Any other example?
Only temperature, maybe.
Can you tell me what is evaporation? In a very simple language, I mean ninth standard language, what is evaporation?
When liquid get converted into gas.
What does that mean? Liquid converted into gas?
Means
Like boiling of
the
water.
molecules of the surface get energized and leave the surface.
Not that complicated. I'm simply asking what does it mean in the simplest possible terms. Suppose Kalu, you are studying in 9th standard, liquid is getting converted into gas. What does that mean?
धुआं.
नहीं मतलब बेसिकली क्या कर रहे हैं आपकी पार्ट
So
इंटर
like
मॉलिकुलर
particles are
स्पेस
like tightly packed when they
yeah
have
in the
tightly
liquid
packed and
particles are nearby and in the gas particles are far away.
far
Okay,
away.
so inter particle space is increasing. So अगर ये बताइए आप, मैं बहुत ही सिंपल से टर्म में आपसे क्वेश्चन पूछ रहा हूँ. There are two particles. One is A particle, one is B particle. In the A particle, attraction is very high. Attraction is high. In the B particle, attraction is low. In which case, more vapor will be formed. In the case of A, the particles के बीच का जो attraction है वो बहुत high है. In the case of B, particles के बीच का attraction बहुत कम है. In the liquid state. तो कहाँ पे वेपर्स ज्यादा बनेंगी?
So A.
आर यू श्योर? ए में अट्रैक्शन ज्यादा है ना? या श्योर बेटा? श्योर. अगर ए में अट्रैक्शन ज्यादा है तो वो वेपर में ज्यादा कन्वर्ट होगा या कम कन्वर्ट होगा? विल इट कन्वर्ट मोर और विल इट कन्वर्ट लेस?
More.
पार्टिकल्स के बीच में अट्रैक्शन ज्यादा है बेटा. पार्टिकल्स के बीच में अट्रैक्शन ज्यादा है तो उनके अट्रैक्शन को ब्रेक करने के लिए, बिकॉज द पार्टिकल अट्रैक्शन बिटवीन द पार्टिकल इज हाई. ओके, लेट मी एक्सप्लेन. बिटवीन बिकॉज द अट्रैक्शन बिटवीन द पार्टिकल इज हाई, so it will be difficult to break that attraction, right? So you need more energy, and if you need more energy, so what will happen? The vapor pressure will be less or the vapor formation will be less. Do you get the answer?
Yes, sir.
I'll repeat again. आपके पास सपोज कर लीजिए ए है. ए में क्या है आपके पास? अट्रैक्शन फोर्सेस हाई है. ओके, देयर आर हाई अट्रैक्शन फोर्सेस. So if the attraction forces are high, you'll have to break them apart and you'll need more energy. More energy is required, and if the more energy is required, then the vapor formation is less. Is that clear now?
Yes, sir.
Write down the second part. Higher the attraction force, higher the attraction force, higher the attraction force between the particle, less is the evaporation, less is the evaporation, and less is the vapor pressure. Is it clear?
Yes, sir.
अच्छा, अभी सब लोग प्लीज ध्यान देना. अब जो पढ़ने जा रहे हो वो एक्सट्रीमली इंपॉर्टेंट है, थोड़ा सा डिफिकल्ट हो सकता है आपके लिए हो, सो प्लीज पूछ लेना इफ यू डोंट अंडरस्टैंड समथिंग. नाउ राइट डाउन. volatile solvent and non-volatile solute. This is the heading. What do I mean by volatile? Something which can be converted into vapor. Something which can convert it into vapor. Non-volatile means something which is not being able to convert in the vapor. For example, stone. If I take a stone, can it be converted into vapor? No. If I take water, is it able? Yeah. Am I able to convert it into vapor? Yes. Is
Yes,
that
sir.
clear? The
Yes,
statement is clear.
Yes, sir.
Okay. Now let's move forward. Let's understand that. Suppose यहाँ पे आपके पास there is only water. I'm taking water as a solvent. This is solvent. Okay. ध्यान से समझना पहले. अगर ना समझना है तो प्लीज पूछ लेना ये. And I have taken bunch of stones. This is solute. ठीक है. This is volatile. So since it is volatile, so there is a vapor generation here, and as a result, there will be pressure here. Pay very close attention. Don't write anything as of yet. I'll give you time, because if you understand this one, everything rest is very easy here. So since the vapor is being converted here, so the pressure will be generated here and it will apply pressure. So this is called P naught. This is read as naught. In case you don't know, this is read as naught. So this is P naught. P naught is the pressure of pure solvent. What is it? P naught is the pressure of pure solvent.
solvent.
And since solute is not being able to convert into vapor, so is there any problem with the solute? Will it convert into vapor or not? Or will it generate any vapor pressure or not? Will solute generate any vapor pressure?
No, sir.
Yes, sir.
या ऑब्वियस बात है, नहीं होगा ना, क्योंकि ये स्टोन्स है, स्टोन्स तो वेपर में जनरेट होंगे. नाउ व्हाट वी डिड, वी एडेड द सोल्यूट इनटू द सॉल्वेंट. सो सपोज कर लेते हैं यहाँ पे ऐसे बन गया. जस्ट ट्राई टू अंडरस्टैंड दिस टॉपिक. नाउ व्हाट विल हैपन, solvent was the pink one, so I'm adding pink here. Now think about it. Earlier it was pure solvent. Now I have added some stones. Suppose kalo they are very light stones. Okay. So some stones will occupy the surface. Some stones will occupy the surface. So what will happen? पहले जितना surface area था, compared to that, now the surface area has decreased or increased?
Decreased.
Decreased. The surface area which is being used for evaporation purpose has decreased now. Suppose पहले कितना था? ध्यान देना. पहले इतना पूरा सरफेस एरिया था जहां से वाटर इवेपोरेट हो रहा था, जहां से सॉल्वेंट इवेपोरेट होता. नाउ दीज टू व्हाइट बॉल्स और व्हाइट स्टोन्स हैव ऑक्यूपाइड सम सरफेस, and as a result the evaporation is not happening as much as it was happening earlier. So this is the pressure of solution. This is called PS. So what is PS? It is the vapor pressure of solution. It is the vapor pressure of solution. Is that clear?
Yes, sir.
I'll repeat again. So based on that, you can add one more thing here. Vapor pressure is proportional to surface area as well. Not okay, don't write that. Vapor pressure is not proportional to surface area. Okay, write a question. Write down a question. Let's see how many of you can think about it. Will vapor pressure depend on surface area or not? That is the question. Will the vapor pressure depend on surface area or not? Okay, that is the question. You have to seek the answer for this and tell me in the next class. It is a very nice question. Okay, now coming to the point, I'll repeat again. पहले क्या था, यहाँ पे इतने सारे मॉलिक्यूल सरफेस पे थे. ठीक है, सरफेस पे इतने सारे मॉलिक्यूल थे, तो यहाँ पे इवेपोरेट हो रहा था. दिस इज अ प्योर सॉल्वेंट. Okay, and the vapor pressure of pure solvent is P naught. Now there is a solute. Solute is non-volatile. Non-volatile solute is stones basically. Say these are stones. Now you have added some stones to the pure solvent. So what will happen as a result? Some stone will occupy the surface. तो पहले जितना इवेपोरेशन हो सकता था उतना इवेपोरेशन अब नहीं हो रहा, बिकॉज जहां पे वाटर के मॉलिक्यूल होने थे वहां पे स्टोन्स के मॉलिक्यूल आ गए. तो पहले के कंपैरिजन में अब इवेपोरेशन क्या है, कम है. Is it clear for everyone? Because that is the foundation of the whole thing that we are going to learn in the next two classes. Any doubt?
No, sir.
Everyone, is there any doubt in anyone's mind? Please send a message or raise your hand, because this is a very important point for you to understand. What is happening in the pure solvent? There was a 100% evaporation. There was no restriction. Once you have added the stones, so stones will occupy the surface, a little bit of the surface that is, and as a result, the evaporation will decrease, because earlier where there was water, now there are white stones. So the evaporation will decrease. Is it clear? Everyone?
Yes, sir.
Okay.
Yes, sir.
If there is any doubt in anyone's mind, please tell me, because you won't understand the rest of the topic if you don't understand this. Okay. So write it down. Write down the topic. Write down the whole thing. First of all, make this picture. First of all, make this picture. Okay. Shall I dictate now? Okay. Write down. In the case of pure solvent, 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 the vapor pressure is P naught as we add the non-volatile solute to it. As we add the non-volatile solute to it, the vapor pressure decreases. Okay. Vapor pressure decreases to PS. Vapor pressure of solution decreases. Write it down like this. Vapor pressure of solution decreases to PS. Okay? Okay. Write down again P naught. Write it like this. P naught is equal to vapor pressure of pure solvent. PS is vapor pressure of solution. Okay? So this becomes, there's a statement that PS is proportional to mole fraction of solvent. PS is proportional to mole fraction of solvent. Just understand this, don't write it right yet now. So if we if we remove the proportionality, it will become mole fraction of solvent into P naught. This is called Raoult's law. This is very important from exam perspective, Raoult's law. So vapor pressure of pure solution is mole fraction of solvent into pure pressure. Write down. X solvent is the mole fraction of solvent. Is it clear?
Yes,
Is it clear,
sir.
everyone?
Yes, sir.
Yes, sir.
Any doubt? Okay.
Yes, sir.
Why did we take mole fraction of solvent? Because out of two things, one was a stone. This is the solute. Solutes are stone or non-volatile. So their mole fraction does not make much sense. Okay. So what is important here? The mole fraction of solvent. Okay. So write down X की value लिख लेना क्या होता है? X solvent is mole fraction of solvent in liquid state. This is Raoult's law. Write down a statement of Raoult's law. A statement of Raoult's law. Okay. Can you make the statement on your own? What is the statement? Read it. How would you read this statement? This equation. How would read the statement? That vapor pressure of solution is proportional to mole fraction of solvent at a constant temperature. Write down at a constant temperature. At a constant temperature, mole fraction at a constant temperature, vapor pressure of solution is proportional to mole fraction of solvent. Any doubt for anyone in this portion?
No, sir.
Any problem? Okay,
sir.
is it clear?
Yes, sir.
Okay. Now coming to the second part, write down volatile solvent and volatile solute. Both are volatile. So suppose here I have taken A. This is A. This is also volatile. So its pressure is PA naught, yeah, plus I have taken B. B is also volatile. One is solute, one is solvent. You can assume any to be any one of them. I mean, you can take A as solvent and B as solute, or B as solvent and A as solute. This is B, and the vapor pressure is PB naught. So when you mix them, you will get A plus B. So let's write some of them. This is B, and this is A. Okay. So what will happen? It is solution because you have mixed them. So this is solution. Its pressure is PS. So can anyone tell me what will be the PS? If you have studied it already, what is PS in this case? Can anyone guess?
PA plus PB.
Yeah. So PS will be C. Now, here there are two portions A and B. Pay attention very closely. There are two portions PA and PB. Now, according to the last one, can I write PA is equal to XA? Okay, first of all, write down the names. Write down PA naught, because as clearly you will write as it will be easy for you to understand. PA naught is vapor pressure of A in the pure solvent. Vapor pressure of A in the pure solvent. While PA is vapor pressure of A in the solution. This is vapor pressure of A in the solution. ठीक है? Write down XA is mole fraction of A in the solution. Mole fraction of A in the solution. This was vapor pressure of A in the solvent. It is going to be a little bit difficult. I told you at the onset. So please bear with me. अगर कोई doubt हो तो पूछ लेना. XA is the mole fraction of A in the solution. Okay. Likewise, what is PB naught? Say everyone with me. What is PB naught?
Vapor pressure of B
In
solvent.
solvent. Vapor pressure of B in solvent. What is PB?
Solvent.
What is PB?
Vapor pressure
Vapor
of B
pressure of
solution.
B in solution.
Vapor pressure of B in solution. What is XB?
Mole fraction of B in
Mole
solution.
of B
Yeah,
in solution.
mole fraction of B in solution. Write down everything. ये लास्ट टफ चीज है, इसके बाद कुछ टफ नहीं होगा.
सर
या
PB नॉट सल्यूट का है कि सॉल्वेंट का है सर?
बेटा, नॉट इज फॉर द प्योर. See, PA naught is vapor pressure of A in the solvent. So PB naught will be vapor pressure of B in the solvent. PA is vapor pressure of A in the solution. PB is vapor pressure of B in the solution. So naught is used always for the pure purpose. Okay.
सर वो मैं सॉल्यूट और सॉल्वेंट का पूछ रही थी.
Yeah. Okay. It doesn't matter because both are liquid. Think about it. Both are liquid. So how do you decide which is solute and which is solvent? You can take any one of them as a solute, and we can take any one of them in as solution. Is that clear?
Yes sir.
So if the A and B both are liquid, then you don't say this is solute. I mean, you can definitely say A is solute, B is solvent, or vice versa. That is B is solute and A is solvent. but it doesn't matter because both are liquids, so you can take any one of them as solute and any one of them as solution. Is that clear?
Yes, sir.
Shall I move forward? So PS can be written as PS is PA into plus PB. Okay. What is PA? According to Raoult's law, what is PA? Can I write PA is equal to XA into PA naught? Because the solution का जो pressure होता है वो मोल फ्रैक्शन इनटू प्योर का जो सोल्यूशन होता है उसके बराबर होता है. ये पढ़ा था ना अभी. P solution is equal to X solvent into P naught. Did we study this or not? So we are
Yes,
applying
sir.
this here. So for A, this is PA is equal to XA into PB naught. PB will be XB into PB naught. So write it down. PS is equal to XA PA naught plus XB PB naught. And XP plus XP because they are mole fractions. So what is the sum of mole fractions? We did it in the last class. What is the sum of mole fractions?
1. 1, sir.
1. So XA plus XP is equal to 1. Okay, what was the formula for mole fraction? If I'm writing XA is equal to, what was the formula of mole fraction? In the last class we did it.
XA
They
plus X,
Number of
XA
moles.
by XA plus XB.
No, mole. This is Na upon Na plus Nb.
Na plus Nb.
Okay. XB is Nb upon Na plus Nb. Shall we do a numerical
Yes, sir.
based on
Yes,
this?
sir.
So,
Yes,
this
sir.
formula is clear for everyone, right? Write down in a solution of 2 mole of benzene, 2 mole of benzene and 3 moles of methane, 2 moles of benzene and 3 moles of methane. ठीक है. Calculate the vapor pressure. Calculate the vapor pressure if vapor pressure of pure benzene is 200 atm and vapor pressure of pure methane is 100 atm. Would you like to attempt it first or do I need to solve it at the beginning? Would you try it
Let's-
first?
Yes,
Sir.
sir.
Okay, try this one. So first of all, calculate the mole fraction. What is the mole fraction of benzene? Did anyone calculate it?
2 by 5.
2 by 5. What is the mole fraction of methane?
3 by 5.
3 by 5. What is the pressure of benzene? Pb is equal to xb into Pb. So that is 2 by 5 into 200. That is 80.
Yes, sir.
What is the pressure of methane? 3 by 5
Yes, sir.
into 100.
Yes, sir.
60. So what is the total pressure? Pb plus Pm. 140.
140.
How many of you got this? Can raise the hand. किसी का आया था?
आ रहा है
Yes,
on
sir.
the way.
Okay.
Yes, sir.
Nice. Shall we do another question? Write down. Okay, let me see the question. Okay, let's do a question. It's a little bit difficult. I mean, difficult to नहीं है. लिखे the vapor pressure of certain pure liquid. The vapor pressure of certain pure liquid A. The vapor pressure of certain pure liquid A is 40 atm. Is 40 atm. When a solution of when a solution of non-volatile solute, P is the non-volatile. When the solution of non-volatile B is prepared in A,
Sir,
yeah,
can you repeat the question?
yeah. Vapor pressure of pure A is 40 atm. Vapor pressure of pure A is 40 atm when when a solution of non-volatile B, is prepared in A, then the vapor pressure of solution, is 32 atm. What is the mole fraction of solvent? It's a very simple question. First of all, you have to decide which is solvent, A or B. What is the mole fraction of solvent? So which is the solvent, A or B?
A.
A is the solvent. So what formula will we use? B is non-volatile. So in case of non-volatile, what do we use?
PS is equals to X solvent into P naught.
So tell me what is the solvent? A is the solvent,
Yes.
and this is PA naught. This is PS. So what will become 32 is equal to XA into 40. Can you solve this one?
Yes, sir.
Is it easy, right?
Yes, sir.
Okay. Okay, so I'll send you more questions, but you haven't solved the previous one. How many will be able to solve this time? I mean, you have the previous uh, classes homework. How many more questions can you solve in this week?
So around 10. No, 8.
Eight questions are too little. Okay, so I'll send a 10 question. Okay,
Yes,
I'll send
sir.
10 question and 25 from the previous class. Please do the homework. Otherwise,
Yes, sir.
it's not helpful. Okay, now we are coming to the easiest part, colligative properties. Okay, now what is colligative properties or what are colligative properties? Colligative properties are those which depends on number of particles rather than nature of particles. I'll explain what do I mean by that. Do you remember the question I asked a while ago? H2, CO2, N2 and ammonia. Which one is the most soluble one in water?
NH3 ammonia.
Ammonia, because it forms the hydrogen bonding. So is it a formation of hydrogen bonding? Does it depend upon the nature of the ammonia or not? For example, some Archana said that it is a polar compound. So it is based on nature of the things, right? Whether
Yes.
someone will form hydrogen bonding or not, it is based on the nature of the things, not the number of the things. So to distinguish that, I gave you this example. Colligative properties are those properties which depend on number of the particle, not the nature of the particle. Write down colligative properties. Colligative properties are the properties which depend on number of the particle, not the nature of the particle. Do you get the point? I'll give you an example as well, don't worry. But do you get the point, the difference between nature? I mean, I guess
Sir,
everyone,
sir.
yeah,
Can you repeat one
yeah,
once
colligative
again?
property, it's okay. Colligative properties are those which depend on number of particles, not nature of the particles. Okay. They depend on the number of particle, not nature of the particle. Is that clear?
Yes, sir.
Yes,
Okay.
sir.
Now there is a very basic question that comes, and it comes a lot. That is, there are four colligative properties. Write down. There are four colligative properties. First is relative lowering of vapor pressure. Okay. So the colligative property is a relative lowering of vapor pressure. Now, what they will do, they will ask you which one is the colligative property, and they will give you the option as lowering of vapor pressure. Is lowering of vapor pressure a colligative property? Yes or no?
Yes, sir.
No, beta, I told you. The property is relative lowering of vapor pressure, not the lowering of the vapor pressure. Is
Yes,
vapor pressure colligative property? No. What is the colligative property that is written there? You don't have to alter a single word. You won't say that lowering of vapor pressure is a colligative property. Colligative property is relative lowering of vapor pressure. Neither is the vapor pressure colligative property. Is that clear? So if I say, tell me whether this statement is correct or incorrect. Vapor pressure is a colligative property. Is it correct or incorrect?
Incorrect.
incorrect.
Incorrect. Is that
Incorrect.
clear? If I say lowering of vapor pressure is a colligative property, is it a correct statement or incorrect?
Incorrect.
Correct, sir.
Incorrect. It is the colligative property is relative lowering of vapor pressure. You'll understand this when we learn it more. Second is elevation of boiling point. Third is depression of freezing point. The last is, there are only four. The last is osmotic pressure. This one you may have studied a little bit in bio. Osmotic pressure. Okay. So now the question is the boiling point a colligative property?
Yes,
No,
sir.
sir.
No, beta. What is the colligative property? Elevation of boiling point, not the boiling point. Is the freezing point a colligative property?
No, sir.
No,
No.
sir.
No,
What is the
sir.
colligative property? Depression of
Depression.
freezing point.
Depression
Is
Depression
that
of
of
clear?
freezing point.
freezing point.
Yes, sir.
Yes, sir.
Okay. Okay. एक चीज रह गई थी मुझे अभी याद आई. Okay. एक चीज रह गई है. There was something that I forgot to tell you. This is the Raoult's law, right?
Yes, sir.
Now, if you draw the graph, okay, this is taken as XA, this is taken as XB. The graph is like this, Peter. This is the graph. This is partial pressure or vapor pressure. This is how the graph of Raoult's law is drawn. This is asked a lot actually, so draw it down. This is the graph of Raoult's law. Okay, now let's learn the relative, write down a heading. Relative lowering of vapor pressure. Relative lowering of vapor pressure. It's a very simple actually. It's extremely simple. Okay. So relative lowering of vapor pressure is basically you have learned PS is equal to X solvent into P naught. Do you remember this one? From 5 minutes earlier, we did that. PS is equal to X solvent into P naught. Everyone?
Yes, sir.
Okay. Tell me what will be X solute plus X solvent? What will be the value of X solute plus X solvent?
1.
1.
1. So can I write in place of X solvent 1 minus X solute?
Yes, sir.
Put the value here. Okay. Put the value here. थोड़ी सी मेहनत करनी पड़ेगी आपको. PS is equal to 1 minus X solute into P naught. Okay. So solve it. I am telling you the P naught minus PS upon P naught is equal to X solute. This is what you will get. See if you are able to do this. After solving this, you will get this value.
Oh.
See if you are able to do that. Those who are able to do that, raise your hand. I mean, after doing this. Okay. What we are learning is relative lowering of vapor pressure. So we have done here PS. We have learned a little bit earlier that PS was X solvent into P naught. That is the vapor pressure of solution is equal to mole fraction of solvent into pure pressure, pure vapor pressure. So we know that X solute plus X solvent is 1. So in place of X solvent, I can put 1 minus X solute. So there I have done this. Now, if you arrange this one, you will get this. So I'm asking everyone to do it on your paper, on your notebook, and tell me when you are done. Raise your hand after you have done it. Nobody got the answer as of yet. How is it possible? जिसका हो जाए हाथ रेस कर देना. आपको यहां से यहां पे आना है. Or otherwise I'll have to do this. You don't have to find anything. I'm saying that you have to rearrange this one, this equation in this format.
Sir,
You have
done.
PS. Okay. Raise your hand after it is done. Okay. One student has done it. Anyone else?
Yes, sir.
Okay. It shouldn't have taken so much time. Rest of you, Nishita, Dristika, Archana, Suhang, Rigzam, Jia.
Sir,
एक
done.
मिनट रुको. कोई नहीं मैं रिपीट कर देता हूँ. एक मिनट लगेगा. देखो. So we are learning the relative lowering of vapor pressure. Did you do that? I mean, तो मैं फिर से शुरू से बता दे रहा हूँ. कुछ लोग बाहर हो गए थे. रिलेटिव लोअरिंग ऑफ वेपर प्रेशर पढ़ रहे हैं हम. ये तो क्लियर है ना कि कॉलिगेटिव प्रॉपर्टी क्या थी? क्यों बेटा?
Yes, sir. Yes, sir.
ओके.
Yeah.
तो रिलेटिव लोअरिंग ऑफ वेपर प्रेशर क्या होता है आपका? कि वही हम पढ़ रहे हैं. पहले उसका मैथमेटिकल फॉर्मुलेशन पढ़ रहे हैं, देन विल एक्चुअली लर्न कि क्या होता है. तो अभी हमने थोड़ी देर पहले पढ़ा था कि जो टोटल प्रेशर होता है जब हम नॉन वोलेटाइल सोल्यूट मिलाते हैं, व्हेन वी मिक्स अ नॉन वोलेटाइल सोल्यूट इन अ वोलेटाइल solvent. So PS was mole fraction of solvent into P naught. Do you remember this one?
Yes, sir.
Okay. Now, can I write in place of X solvent 1 minus X solute? Because in a mixture, in a solution, there are only solute and solvent. So since there are only two things, the sum of real mole fraction will be 1. So can I write it like this?
Yes, sir.
Okay. Now see, PS is equal to P naught. I'm opening the bracket. P naught into X solute. Okay. Now see, I'm arranging it. I'm rearranging it. So P naught minus PS, and I'm sending this one this side and this whole thing this side. So P naught X solute. Is it clear? Everyone, is this clear?
Yes, sir.
Okay. See, now, can I write it like this? P naught minus PS upon P naught is equal to X solute. Is it clear now? Yeah. बच्चे क्लियर है अभी? हेलो, क्या दिक्कत क्या आ रही है तो बताइए आप.
सर
कोई नहीं
वो
हाँ बताइए.
सर वो x माइनस 1 माइनस x सॉल्यूट पी नॉट है ना सर, उसके नीचे से मतलब
ओके,
वहां से.
तो इसको हमने ओपन कर लिया. ब्रैकेट तो खोलना आता है आपको. तो यहाँ पे ये इधर आया पी नॉट माइनस पी नॉट इंटू एक्स सॉल्यूट. इज दैट क्लियर नाउ? लेट्स गो लाइन बाय लाइन.
Yes, sir.
Okay.
Yes,
Now,
sir.
I'm sending this one on the right hand side and this whole thing on the left hand side. Or wait a minute. Let's simplify this further. Can I write it like this? PS minus P naught is equal to minus P naught into X solute.
Yes, sir.
Okay. Now, can I take minus common from this side? So it will become minus of P naught minus PS is equal to minus of P naught X solute. If I take minus common from this side, is it clear?
Yes, sir.
Now minus minus will cancel off. Minus and minus will cancel each other. Is that clear?
Yes, sir.
So this will become this one. No? See?
Yes, sir.
So that is what we have written. This is now, is it clear or not?
Yes, sir. वो ब्रैकेट खुला है, मतलब ब्रैकेट खोलना है बोल के वो मैंने
हाँ बस
ध्यान में
ब्रैकेट
नहीं
खोलना है.
दिया.
ठीक
Yes,
है.
sir.
So P naught
ठीक है,
minus PS upon P naught is equal to X solute. This is called, this whole thing on the left hand side, this is called relative lowering of vapor pressure. ठीक है. This thing is called relative lowering of vapor pressure. Is it clear? Why we
Yes.
did the formula? Because the left hand thing is called relative lowering of vapor pressure. So can I say relative lowering of vapor pressure is equal to mole fraction of solute? Can I say that? Everyone?
Yes, sir.
Yes, sir, we can say that.
Write down the statement. Relative lowering of vapor pressure is equal to mole fraction of solute. आगे बढ़े.
Yes, sir.
Yes, sir.
Write down if n. So this is the formula that we got. Let's elaborate it a little bit more. Write down if n is the number of mole, if lowercase n is the number of moles of solute and uppercase n is the number of moles of solvent. So what will be the formula, beta? What will be the formula now? P naught minus PS upon P naught is equal to, what will be the formula? What is the formula for X solute? Mole fraction of solute can be written as
Small n.
lowercase n upon okay.
Yes, sir.
Okay, what is P naught? बेटा एग्जाम आपका शायद स्क्रीन पे कंट्रोल है तो आप लिख पा रहे हैं, उस पर ड्रॉ मत करिए. ओके राइट. व्हाट इज P naught? Let's do a question. What? Just repeat after me. What is P naught?
What is P naught?
Yeah, this P naught. What is P naught?
Vapor pressure of pure solvent.
Yes, this is vapor pressure. Everyone, please repeat it. I mean, Even in your mind that would do, but if you don't repeat it, you won't remember it. P naught is the vapor pressure of pure solvent. PS is
Vapor pressure of
Vapor
solution.
pressure of solution.
vapor pressure of
Pressure of
solution.
solution.
So P naught is the vapor pressure of pure solvent. PS is the vapor pressure of solution. Okay, X is the solute. So, okay, let's do a question. Right on. Vapor pressure of an aqueous solution of glucose. Vapor pressure of aqueous solution of glucose is 700 mmHg. What is the mole fraction of glucose? What is the mole fraction of glucose? Okay, before I move forward, just tell me, I told you in the equation, what is it? Aqueous solution of glucose. So what is it? PS or P naught?
Water.
This
Huh?
is PS or P naught?
PS.
This is PS. Okay. Now, before solving this, mmHg, it is not mHg, mmHg. Before solving it, what is the solvent here? Pure solvent. What is the solvent? Just read the question carefully and tell me what is the pure solvent here.
Water.
Water. Water is the pure solvent. Can anyone tell me what is the P naught or what is the vapor pressure of water? From physics, you must have learned somewhere.
760.
760. Yeah, 760. Who told the answer?
Archana.
Okay, mmHg. This is the P naught. This you have to remember. The pure water, the aqueous, the vapor pressure of water, that is called also aqueous tension, but the vapor pressure of water is 760 mmHg. So now do the solution. All you have to figure out is X of glucose. All you have to do is solve for the glucose.
So 60 by 760.
Yeah, 60 by
760.
760. Easy, isn't it?
Yes, sir.
Yes, sir.
Okay, let's do another one. In the next class, we'll do a little bit
Sir.
difficult question. Yeah. हाँ बेटा बताइए क्या डाउट है? I think someone asked something. Okay, let's do another question. Right on. Calculate the relative lowering in vapor pressure. Calculate the relative lowering in vapor pressure on addition of 4 gram glucose to 500 या 54 gram 500 gram water. Calculate the relative lowering of vapor pressure when 4 gram of glucose is added to 500 gram of water. Would you try it or should I solve this first?
So can we try?
Yeah, sure. अच्छा ग्लूकोज जिसको नहीं पता है C6H12O6 होता है, कार्बन is 12, oxygen is 16. So this turns out to be I think 180 or something. You have to calculate the relative lowering. This is it, which is equal to X of solute. On X of solute is number of moles of solute upon number of moles of solute plus number of moles of solvent. So what
So
is
can
the
it
solute?
come in
Water or
decimal?
glue? Pardon?
So can it come in decimal?
I don't. Yeah, I have to calculate it. Let's see. So see, what is the solute? Glucose or water?
Glucose.
Glucose is the solute. Mass of glucose is
4
4 gram.
grams.
4 gram. What is the molar mass?
192.
180. It should be
So
180,
180.
beta.
180.
Oh, sorry.
Okay. So the number of moles of that is lowercase n is 4 by 180.
That is
Now coming to water,
approximately
mass of water is
500 grams.
500. Molar mass.
18.
18.
So all you have to do is put the values there.
Yes, sir.
So how much? What is the answer that we are getting?
So I think, I'm not sure, but the answer is 0.00798.
0.0079 something. So everyone can check this one. Okay. Is it clear?
Yes,
अच्छा
sir.
एक क्वेश्चन, बस एक क्वेश्चन और होता है इसमें समझना. अभी तक हम केवल बात कर रहे हैं रिलेटिव लोअरिंग की. ओके, दिस इज द रिलेटिव लोअरिंग. नाउ लेट मी आस्क, आई हैवंट टॉट यू दिस, बट लेट्स सी हाउ मेनी ऑफ यू कैन गेस. If this whole thing is relative lowering, what is this thing? P naught minus PS only. What would we call it? P naught minus PS. Just take a guess. It's okay. I haven't taught you this. If the P naught minus PS upon P naught is the relative lowering, then P naught minus PS is
Decrease in vapor pressure.
Can you speak a little bit louder?
Decrease in vapor pressure.
Yeah, or lowering in vapor pressure. This is simply decrease in vapor pressure or lowering in vapor pressure. So sometimes they may not ask you the relative lowering. They may simply ask you lowering in vapor pressure. So at that time you have to tell them the value of P naught minus PS rather than P naught minus PS upon P naught. Is that clear, everyone?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay, so P naught minus PS is the lowering of vapor pressure, while P naught minus PS upon P naught is the relative lowering. So you have to read the question very carefully because people do make mistake in this one. They don't read the question properly, and instead of finding lowering vapor pressure, they give out the answer for relative lowering in vapor pressure. And sometimes instead of solving for relative lowering, they solve for lowering. So shall we do a question?
Yes, sir.
Write down. Let's take a simple one, right? Values should be simple, that is. Let's take 49 gram of H2SO4. 49 gram H2SO4 is added to 90 gram of water. What is the lowering in vapor pressure? Okay, I told you in the last question, what is the value of, first of all, out of H2SO4 and water, which is the solvent, H2SO4 or water?
H2SO4.
With a solvent.
Water.
Water.
Water is solvent, right? And what is the P naught value of water?
Huh?
What is the P naught of water? I told you, you have to remember the value.
760.
760.
760. Now try to solve this. Okay, let's see. So there has been given to you mass of H2SO4 as 49. Molar mass
4.7.
is 98. So number of moles, that will be 1 by 2. Mass of water is 90. Molar mass 18. Number of moles 5.
5.
Okay. So P naught minus PS. This you have to calculate. Divided by P naught. That is 760. Half of 5. This is the equation that you will get. How many of you got this?
Yes, sir.
Okay. So you are able to solve the questions, right?
Yes, sir.
Okay. What happened? All of you seem very tired. Did you have a school or something?
No, sir.
So we
Thank
had.
you. Okay.
Kind of.
So, shall I give you a question for? I mean, I'll send the question as well, but let's see if I get a nice question.
Okay, sir.
Answer is 6 point something.
Yeah, I think it will be 760 into
Div-
2 to cancel 5 to 11, 1 upon 11.
Yes,
So
sir.
Yes,
that
sir. 1
is,
upon 11.
yeah, 760 into 1 by 11.
Yes, sir.
It will be
So
6
that
point.
is 6 point something, right?
Yes, sir.
Yes, sir.
Sorry, 6 not, 60 point something.
60. Oh, yeah.
Yeah. This is 0, no?
Yes, sir.
Okay. Write down a question. Ethylene.
Hmm?
Write down a question for homework. I mean, I'll send the question as well, but at least you will have to do one question. Ethylene. Ethylene is C2H4. Ethylene is C2H4. And propylene. Propylene is C3H6. Form a solution. Form a solution. Form a solution in which ethylene is 10 gram. Ethylene is 10 gram. Propylene is 20 ग्राम या 80 ग्राम ले लेते हैं 80 ग्राम आपको दिया गया प्योर एथिलीन दैट इज पी नॉट ऑफ एथिलीन आई एम नॉट stating the question in the pure framework that is as it is written. I'm giving you proper the values so you can able to solve this. P naught of ethylene is 173. P naught of propylene is 123. This is the question. Okay, now what you have to figure out, write it down. Calculate the partial pressure of each component. Calculate the partial pressure of each component in the solution. And total vapor pressure. Raoult's law का क्वेश्चन है ठीक है and total vapor pressure. ठीक है थोड़ी सी टफ थी आज की क्लास. So what we'll do, revise this, and if you have any doubt in the next class, we'll take half an hour to revise this portion. Is that okay? आप लोग पढ़ के आएंगे ना इस बार?
Yes, sir.
Yes,
पिछली बार नहीं करके आए तो
Sir.
पढ़ के आना प्लीज वरना आगे और दिक्कत आ सकती है जैसा मैंने कहा केमिस्ट्री बहुत स्कोरिंग है बट आपको पढ़ना पड़ेगा तो प्लीज पढ़ के आना विल टेक 15 to 20 minutes to revise this जो भी आपको डाउट आया होगा जो भी नहीं आता होगा विल टेक half an hour or 15 to 20 minutes and revise this. Is that okay?
Yes,
yes,
sir.
sir.
ठीक है तो बट पढ़ के आना है आपको
Okay, sir.
ठीक है
Okay, sir.
चलिए दिस इज ऑल फॉर टुडे गुड नाइट एवरीवन